For this bell work, we got a radius of a circle that is 19 centimeters. We will find its circumference in terms of pi. And hopefully remember the formula for the circumference of a circle, but probably don't. So it's 2 times the radius times pi. Now it says it wants the answer in terms of pi. That just means that we're going to have the answer have a pi in it. The pi symbol there. And so we look at this one, we see that the radius was given to us at 19 centimeters. So I replace the R for radius with 19. And you can just put this in the calculator, but 2 times 19 there, you're going to give us 38. That's how many pi's there are. 38 pi is really all we need. And yeah, we'll just label this one in centimeters, I guess. Don't forget the label. Yeah, 38 pi centimeters. That's the answer in terms of pi. If we wanted to change this into a decimal, which we could, you just push the double arrow button right above the enter button, and then it will do that for you. Here's the objective then. I can interpret probability situations as impossible, unlikely, equal chance, likely, or certain. Take 30 seconds and copy this down, please. All right, so probability is just the chances that something will happen. Of course, this is a math class, so we're going to be looking at being able to do this numerically, which really isn't too bad. So we have 2 different types of probability, experimental and theoretical. You'll never be quizzed, at least this year, on this vocabulary, but maybe in some future class you could. Experimental probability is just based on something that has already happened or based on some kind of research, surveys, studies, or questionnaires. Now, probability is generally used for future things, and so it is also highly manipulated in many surveys, studies, and questionnaires. One of these ways that it is, one way that it's very highly manipulated is in research based on the Earth warming and cooling. That type of information is very highly manipulated, but it's based off of things that they say have already happened. That would be what we call experimental probability. And that would be based off of a study. But again, it can be highly manipulated. If it's some kind of fair research, then generally speaking, they will just kind of give you the statistics, which then you can figure out those probabilities on your own. So, for example, let's look at maybe like a questionnaire. A questionnaire asks people, you like the color orange? And if 75 people say they like the color orange, then you could say that let's say that you asked 100 people and only 75 people said they like the color orange. Maybe the other 25 said that they hate the color orange. Well, since 75 people said that they like the color orange out of 100, then you could say that it's likely that if you asked another 100 people, that around 75 people would probably say that they like the color orange out of the 100 people that you would ask. Now, would that actually happen? I don't know, because you probably would want to ask different people, but I suppose you could ask the same people and then you could kind of guarantee the results of your questionnaire. But again, that's how these can be manipulated as well. Theoretical probability is based on or it's kind of like how you predict something that could happen without actually doing the thing or before playing a game, maybe before some kind of situation occurs. So theoretical means nothing has happened, but you can see what you're dealing with, and then you could make these types of observations, like dice, for example. Cards, of course, yeah, that's how a lot of people play poker. They play the odds, which are just another way to say probability. Of course, some people play people, and that's different. Spinners as well, something like the Wheel of Fortune, or maybe landing on a space like you would in the game of Monopoly. You can figure out those probabilities before you ever roll the dice, before you ever spin the spinner, or before you ever draw a card. It is possible to figure out those probabilities, those chances that something could happen. Probability will be found in fraction form. So it's how often something can happen. So if it could happen or can happen, that's based off of theoretical. If it based on something that does happen, then it would be experimental, something that has already happened. Okay, so you look at these things and you say we divide that in the denominator with the total number of possibilities or results. Possibilities would be theoretical, results would be experimental. So let's look at an example here, and we'll figure out some probability. Okay, so let's say that we have a dice, and let's say that we want to roll a 6. Okay, well, we'll make this a fraction. Now, the first thing I would probably figure out on this one is how many total possibilities are there. Well, it's a 6-sided dice, and so there's 6 different numbers on each face. So there's a total of 6 different possibilities that could happen on the dice. And again, this is before I would actually take a roll of the dice, which makes this theoretical. Okay, well, how many of those numbers are an actual 6? Only one of them are. So how often could that thing happen? It's only one face out of the 6 faces on the dice, so there's a 1 out of 6 chance. All right, about to emphasize this, let's change this just a little bit. Instead of rolling a 6, let's say that we wanted to roll an even number, which could happen from time to time. Well, then you'd be looking on the dice at the numbers 2, 4, or 6. Well, that's 3 possibilities, 3 possible faces out of the 6. And so you'd say you'd have a 3 in 6 chances. This is a little bit more explicit than reducing it, because if you change this to 1 out of 2 chances, then what you're saying is 1 out of every 2 faces on the dice are even. Now, that doesn't really tell us how many total faces there are, but this one pretty much does. Or if we wanted to state that explicitly. Of course, in today's lesson, you'll also need to know how to change these into decimals. If you wanted to change a fraction to a decimal, you just simply divide 1 divided by 2, and you get 0.5. If you wanted to change this to a percent, you would move the decimal 2 times to the right, or you could multiply by 100, which would also make this 50%. And in the objective today, 50% is crucial because it's where things split, generally speaking. Because for today, we're really only looking at what will end up being like 2 different options for the most part. So that's just a tiny bit of exposure to this. So let's go back, and we've got to figure out how to change fractions, decimals, and percents. Now, there is a process to these. Okay, or you could say, well, look, if you wanted to change a percent to a decimal, down here in this one, percent to decimal, you could just move the decimal 2 place values to this one would be to the left. And we know you could change decimals to percents. I guess we just kind of saw that one. This one, it's just the opposite of the next one. You could move the decimal 2 place, I spelled 2 wrong in that other, 2 place values to the right for this one. There we go. Now there is a different way. There's a different method, and this is the only method that I'm going to be using, and this is the calculator method. Just understand that when we see probabilities like we see here, we generally start with some type of fractional value. Until you get a little bit more experience, then you could start with decimals or percents. But for the most part, we'll probably be looking at fractions and then changing the fractions to decimals and percents. But we're going to look at each of these. If I want to change a fraction to a decimal, then on the calculator, really all you got to do is divide the 2 numbers. So you could just use the division button. If you like. But if it gives you a fraction, then recall that you could just use the double arrow button, which is just 1 button above enter. Okay, so fractions and decimals aren't too bad. And we know decimals to fractions also. Again, if the calculator gives you a decimal, you can change it into a fraction with the double arrow button as well. And again, that's just 1 button up from the enter button in the bottom right of the calculator. Let's look at these other ones. We got to change a fraction to a percent. So if you want to change a fraction to a percent, so you could start with some kind of fraction. Maybe it's in the n over d stuff. The truth is that it won't really matter if it's a fraction or a decimal. All you're going to do is you're going to push, in fact, I'll put it over here. In the top left of the calculator, you're going to see a second button. The ones that we have are green. You're going to see the second button. And then this tells us that we're accessing the second function of each button on the calculator. Well, this is a convert to a percent button, which is it's the close parentheses button, but you'll see right above it there's an arrow with a percent sign next to it. So what this tells us here is please calculator, change whatever this number is into a percent, and it will. And then of course you'd have to push enter after that. But yeah, the calculator knows how to do that. In fact, what I've shown here for fractions to percents, you do the same thing for decimals to percents as well if you wanted to. All right, so that's the same for both of those. Let's see, we also got percents to decimals. Well, it is possible that maybe sometimes you could even type in a percent. If you wanted to type in a percent, then what you got to do is you type the number that you want, and then you push the second button. And again, this is to get a percent on the calculator. You type the second button, and then it's the open parentheses button, which again, it's the second function of that button, which you can see right above it is the percent sign right there. So that's how you'll get a percent from the calculator if you wanted to type in a percent. So if you wanted to change a percent to a decimal, then all you got to do is type in the percent, whatever it is. I guess I can copy this over here then. So percents to decimals, you're going to type in your percent like this, and then all you got to do is push the enter button. And the calculator will change this immediately to a decimal for you. Okay, so now we're done. So what have we got? We did fractions to decimals, percents, fractions to percents, decimals to percents. Now percents to decimals, decimals to fractions. We got this last one then, percents to fractions. So if you start out with a percent, you can change it into a decimal first. So again, that's pretty much the same process here that we just went over, like this. So if you start with your percent, this will change it to a decimal. Now, without pushing anything else after you push enter, if you just push the double arrow button, that will change that decimal into a fraction for you. Okay, and the nice thing about the calculator is it will change, or if you ever change it to fractions, it will simplify it for you, which will be a requirement on the assignment. Let's look at this first example. Let's change this fraction into a decimal and also a percent. So let's start with, again, I would just type this into the calculator first. So I'd type 11, and then I would use the N over D button because that will give us the fraction. It'll even show us a fraction on the calculator, but then I'd type in 25. Okay, now you could push enter on this, and it would just give you the fraction back. Really, all I'm going to do is push the double arrow button on my calculator. Oh, I apologize. Make sure you get out of the fraction first. So before you type in the double arrow button, you got to get out of the fraction. Or you could push enter. It doesn't really matter. But on the cursor, you got to push to the right, or I think it's just to the right, and then you push the double arrow button above enter. And then it changes this into a decimal for me. So my decimal is showing as 0 on the calculator, 0.44. That's my decimal right there. Now I also want the percent, right? So from the calculator right here, I push second, and then the close parentheses button here. Now you can see on the calculator, it shows just above the same symbol that's just above the close parentheses. It's the arrow percent right there. And then all I got to do is push enter. calculator's on. There we go. Yep, and this changes this into a percent for me at 44%. So we do have both answers now. We have the decimal, and we have the percent. But again, I'm just using the calculator to do this. I think some of you guys seeing the decimal, to change it to a percent, you may have just moved the decimal 2 times to the right, and that would work too. But for those of you that want to keep using the calculator, you can. Convert 25.1% to a fraction and decimal. All right, no problem. So again, I'm going to type in my 25.1% into the calculator. So 25.1. I want the percent symbol. So I push second. And then it's the open parentheses button, which does have the percent symbol immediately above it. And all I got to do from this point is just push enter. So this will change this into a fraction for me. My fraction shows, oh, I'm sorry, no, this is going to change this into a decimal. And it changes it into a decimal for me, 0.251. So that's my decimal value right there, 0.251. Now again, just to change this into a fraction, not too bad. It's just the double arrow button above the enter button. And the calculator, just by pushing this without pushing anything else, this changes it immediately into a fraction for me as, not a very pretty fraction, but 251 over 1,000. And that's all it asks for us on this one. We have the decimal. Now we have the fraction. Convert this decimal to a fraction. So again, I'm going to go straight to the calculator. I'm going to type in 0.513. Okay, now since I do want this as, I guess I can start with a fraction, although it doesn't really matter. But I would push the double arrow button, and then I would push the enter button. And this changes this answer right here to a fraction for me right away. It's 513 over 1,000. Now again, without pushing anything else, I will access the second function. So I'm going to push the second button in the top left. I want to change this into a percent next, rather. So that's the close parentheses button, which again, it has the arrow and the percent sign above it. So that tells the calculator, please convert this into a percent, which it will do as 51.3%. So again, that's our percent right there, and we already had the fraction. That 513 over 1,000, it may not seem like it's simplified, but it is, because the calculator will always simplify those if it can. But since it didn't, that's just what it gave us. That's what we know that fraction would be. Now keep in mind on the assignment, sometimes it may have like a little extra space here for numbers that repeat. Remember that we use bar notation for those. If a number repeats, you have to put that number under the bar. If it doesn't, then I think you just keep it blank. I guess you could put zeros there, but I forget on the assignment which one it wants. So this goes back to the objective here. We got to look at situations that are impossible, unlikely, equal chance, likely, or certain. If it's impossible, there's just no chance that something, whatever it is, could happen. If it's unlikely, then you get a less than 50% chance, but it has to be more than 0% because exactly 0% is impossible. Now for equal chances, if we're looking at two options, which is pretty much all we're going to be looking at today, you need a 50% chance. If there were 3 options, then each of the possibilities would have to have a 33.3% chance. You can repeat that decimal if you'd like. If there were 4 options, then you'd have to have a 25% chance or a 1 in 4 chance for each of the options. Likely would be considered something that's more than 50% chance. And if it's certain, then it would be an equals 100% chance. So we're just going to be classifying these. Sometimes they'll ask us to say, well, which of these is certain? Then you got to read the situations and determine which one is which. But we should be able to classify these pretty simply just by using the probability fractions that we've been seeing already, and then maybe changing these into percents. But we know how to do that with the calculator. This one says your school is selling 100 raffle tickets to raise money for a new gymnasium. The grand prize is a 10-speed mountain bike. Which word or phrase describes the probability that you will win the raffle if you buy all the tickets? So just as a quick reminder, remember that impossible means that there's exactly a 0% chance. Unlikely is less than 50%. Or less than 1/2. An equal chance means it's exactly 50%. Likely is more than 50%. And then certain is exactly 100%. Okay, now when we talk about probabilities, we're not talking about this like effort, like give 110% effort, whatever the crap that means. Okay, so 100% is really the maximum that we can look at when we look at probabilities. So this one, what does it tell us? Well, let's make a fraction out of this. It says that there's going to be a total of 100 tickets, right? So I know there's a total of 100 tickets. That's my denominator. It says also that you're going to buy all the tickets. That would indicate that you're purchasing 100 tickets, which is 100 over 100. If you were to change this into a decimal, it may even show 1. You could, just to emphasize the percentage, you could show 2 zeros after it, which then this would change into 100%. Well, that's exactly 100%, which means that this situation right here is certain. You want that mountain bike bad enough, now you're willing to spend however much money each ticket is. Maybe you just got them somehow. But you're guaranteed to win this contest. It's certain. Well, let's say you buy a ticket for a raffle with several prizes. The probability that you win a prize is 0.5. Now, just to clarify, I do want to see this as a percent, because that's kind of what we've been comparing this as. So that'd be 50%. Yeah, some people say move the decimal 2 times to the right. Doesn't matter. As a fraction, that would come out as 1 out of 2. Okay, now you could even ask at this point, well, how's there only 2 options on this one? Well, you can either win or lose. So that's why there's 2 options. Which word or phrase describes the probability that you will win a prize? Well, that's a 50% chance. That's an equal chance, as far as we've seen. Remember, impossible 0%, unlikely is less than 50%. An equal chance is exactly 50%, which is what this is, which means that we're looking at a situation that's not likely or certain either. Remember, likely is more than 50%. Certain is exactly 100%. Now, we did that kind of quick. Since this is kind of new for you guys, you may have to think about this just a little bit. Maybe some of you guys a lot. But you can see also that it's not actually that difficult. In fact, there's not really much calculation going on. And if there is, I make the calculator do the work for me, which I would encourage you to do. Now we have this situation. So it says we want to figure out which of these contexts is or would be described as likely. And we need to remember that likely indicates that we're looking at something that's more than 50%. More than a 50% chance. All right, so we got rolling an odd number on a standard 6-sided die numbered 1 to 6. Spinning a spinner divided into 4 equal sized sections colored red, green, yellow, blue, and landing on red or yellow or green. The third situation, winning a raffle that sold a total of 100 tickets if you bought 0 tickets. And then finally reaching into a bag full of 17 strawberry chews and 3 cherry chews without looking and pulling out a cherry chew. So this is a good practice one for us. You guys take a minute, see if you can figure this one out, and see if you can classify the other ones as well. See if you can classify all 4. Again, our main objective on this one is just to figure out which one of these is likely. Take 1 minute, try this out, and then we'll go over it together. So this first situation here, rolling a 6-sided dice, well, we've seen that already. So as a fraction, there's only 6 possible faces, 6 options, 1 through 6. Now, I did say I wanted to roll an odd number. That would be the numbers 1, 3, and 5 on the dice. Well, that's 3 different options out of the 6, which as a decimal would be 0.5. This one here changes as a percent to exactly 50%, which means that this one right here is just an equal chance. Okay, so it's not that one. How about this next one? Spinning a spinner divided into 4 equal sized sections. Okay, now equal size is important. So if they're not equal sized, it does change the probabilities for us, but we're not worried about that. We're just getting a little exposure to this. So as a fraction, let's start with the fraction here. So there are 4 equal sized sections, so there's a total of 4 sections on this spinner. It did tell us the colors, but it also said that it wants us to spin. It could be red or yellow or green. That's, as far as I can tell, 1, 2, 3 different options of the 4. So it's asking what are your chances of spinning one of those 3 out of the 4. That's 3 out of 4, which as a decimal would come out as 0.75, which is also 75%. Okay, now from what we've seen, that's what we would consider likely. Okay, so the one that we wanted actually was this one, the second one. I don't know, I guess I can circle that one. Now, let's look at the last 2 because these ones aren't too bad either, but it says winning a raffle that sold a total of 100 tickets. Now that's the total right there, so in our fraction, we already know it's out of 100. But it says you're going to purchase 0 of them. Well, that's a 0 or 0% chance. This one would be impossible if we were to classify it. And then the last problem, reaching into a bag full of 17 strawberry chews and 3 cherry chews without looking and pulling out a cherry chew. So we would want to first kind of think about how many total there are on this one. Okay, now the thing is you have 17 strawberry chews and then another 3 cherry chews. That totals 20 chews that are in the bag. But it says you're going to pull out cherry. Well, there's only 3 of the cherries on this one. So that's 3 out of 20 as a fraction. Of course, we know that we can change this into a decimal. This would come out as 0.15, which as a percent would change into 15%. Now 15% is less than 100, less than 50. So this one right here would be considered unlikely to happen. Now I think some students want to say something like, well, what if you looked in the bag? Then you could kind of have a better chances of getting it. Yeah, that's true, but we're just kind of without looking at it, so it's kind of a random thing on this, which is important. Randomness is important when we talk about probabilities most of the time. But yeah, it's the second one that would be considered likely. Here's our objective. I can interpret probability situations as impossible, unlikely, equal chance, likely, or certain. And hopefully we feel pretty good about that.